I'm Miles.
I'm Ty.
I'm Jack.
I'm Chris, and we did our project on sustainability of electric vehicles.
To contextualize the problem, electric vehicles and their production has actually caused more pollution because of the battery mining. This is globally a problem because mining is everywhere in the world, and electric cars are becoming more popular and used in more countries. Many consumer problem is just price of electric vehicles and batteries and pollution effects for them. So the lenses we'll be exploring today is environmental, social, economic, and futuristic.
Our guiding question was, how can we make the production of electric cars have less negative effect on the modern world? And our solution for this was to improve sustainability of battery mining and battery recycling.
How could we implement this? A great way to implement this is to create a drive for people to recycle their batteries. We could give them a small portion of money for their batteries to increase a higher rate of recycles. We could create advertisements and awareness, such as articles, billboard, commercials, so more people are aware of this problem and we can find a way to solve it. We can also enforce laws to make sure that people who are found of disposal, we can penalize them for what they're doing because it could be against the law.
So the first topic or lens that we're going to be looking at is the environmental. From the first quote is 1 ton of mined lithium emits nearly 15 tons of CO2. And in this graph, you can see that in 2025, there will be approximately 4.5 million tons of CO2 released from lithium mining alone. This leads to types of pollution such as ground, water, and air pollution, which are detrimental to the environment. So the first is water, ground, and air pollution. In this visual, you can see many different aspects of lithium mining leading to different kinds of pollution. One being sedimentary ore deposits, which lead to soil pollution, which then can lead to our human health, causing more problems. Our solution reduces air pollution, ground pollution, and soil pollution because it cuts the needs for new materials, it prevents heavy mining companies from leaking heavy metals, and it cuts the water amount used because we don't have to mine as much. Next is the water intensive and decreased production. This quote, since mining of lithium is very intensive, especially in arid regions, its overuse can destabilize local ecosystems and impact community lifestyle. Our solution protects the environment at lithium extraction points because the salt flats that they're mined at are heavily dry and arid. So our solution also decreases the demand because we can recycle the old material and keep it in use. It also helps preserve the environment for future generations, which is crucial given that this industry is growing and not dying.
So the social aspects we found are labor forces, health risks, abusive employers, and then the positive that we found is incentives for urban growth. So the overbearing problem is labor abuse. Because of the high demand for batteries, there have been more people needed to mine these materials. And another thing is that these businesses have been neglecting their employees. So the one thing that a lot of miners have been lacking is PPE, personal protection, and that's such as helmets, masks, things like that. So a lot of people have been dying, and as you can see in this graph, there's about 6,000 people globally that die each year. And then in the DRC alone, there's about 2,000 for cobalt mining. These mines are not being penalized for what they're doing and are mainly underlooked. And this needs to change so we can enforce those laws and make sure that this doesn't happen.
So contrary to the negatives that I found that this lithium mining led to urbanization of many rural towns. For instance, that the amount of lithium mines can grow the town, but our solution can change it to recycling. By recycling the new materials, we can decrease the intense mining, saving the social lives of the people, but we can also allow for more advanced technology into the towns. This would also diversify the economy and improves the types of jobs available, and then the education system would have to be more advanced to support the newly found industries.
Our third lens focuses on the economic field of EVs and their batteries. On one hand, the demand for EVs will be greatly increased and provide a better market because instead of biasing larger companies, it allow for smaller companies to also rise and distribute sales to make a more balanced and well-sustainable market. On the other hand, however, it'll likely also increase overconsumption and put promising positions for investors and consumers because it'll jeopardize the stability of the national grid.
As you can see with the display on the screen, it shows U.S. petroleum product consumption in million barrels per day. It peaks at 14 million per day. And once it hits that 2020 mark, the transportation sector takes a big dip because that's when electric cars really started to come out into production. If we can continue this decline with oil consumption, that gives us more oil to ship out to other countries, especially lighter crude oils, which we can charge higher premiums for, which just fuels the economy. So, diversification. Overall, the transportation sector accounts for approximately 30% of total U.S. energy needs and 70% of U.S. petroleum consumption. So, diversifying the U.S. transportation fleet leads to a more sustainable energy grid and potentially less risk of cyber attacks from sovereign countries. And this also produces more electricity and better energy results in more energy security.
Our second focus is on high demand. Concentrated demand leads to more production and as a result will lead to insufficient resources. As it stands now, materials like lithium and cobalt are already very scarce, and as it stands now, that won't be changing. A quote from a scholar of Blue Creek University states that, however, there's a current trend in increasing the battery size in order to improve the range of EVs, but is unfavorable to CO2 emissions. So this leads back to the very common instabilities found within EVs, whether it be the range, the price, the cost, or if it'll be a stable investment. The graph itself demonstrates the rapidly increasing market of EVs, and as you can see from the years from 2015 to 2021, the European Union, China, and the U.S. have been seeing a great increase in numbers, and it shows that more people are willing to buy EVs of different varieties, which as a result will lower the cost of fuel compared to internal combustion engines, but still does not change the stability that they currently face, which is unfortunately bad.
So the final lens that we're looking at is the futuristic lens. We're going to be looking at the predicted effects of our solution and the plans of major companies and how they play a role and how our solution helps. So the first is the predicted effects. In this graph, you can see that the industry is not stopping, it's leveling off. So our solution accounts for the growth and decay of the market. But it also allows for different kinds of growth, such as the recycling and mining industry, which is good for both rural towns and major companies.
If larger companies such as Kia or Tesla choose to implement our solution, however, it would make larger companies more plausible because it would make the market itself more sustainable and eco-friendly. Moreover, it makes a market that is it's beneficial for both investors and consumers because it fluctuates both in their favor because it'll allow for large companies to develop more for EVs and also for the more adaptability to the current economy. The visual from the 2024 Kia Investor Day demonstrates their current numbers, plans for the future, and their production rates. And as it stands now, their production rates will continue to increase. And in order for them to reach their goals, recycling could be the answer to that, because EVs are still increasing as it stands now, and they will not go away. Because of the complexity of our solution, it still has a lot of limitations. One of which being its inefficiency. Because in order for lithium batteries to be recycled, all of the radiant material needs to be dormant or taken away in order for the process to start. Moreover, it's really hard to implement into large companies and it's very cost heavy. The implications also are that the greatly reduced mining, which will be focused more on the recycling. On top of that, it's economically beneficial because instead of wasting all of the money on mining, it can be focused on recycling, which will make a more stable market. On top of that, it's better living conditions because it minimizes waste and also CO2 emissions.
Our alternative solutions will reforming infrastructure and production cuts.
Our first alternate solution is reforming infrastructures which implies that we take our current charging stations and upgrade them in order to enhance the power grid, which as a result makes EVs more sustainable, gives them a more stable market and a consistent demand. Although the cons stay the same with the scarcity of the materials and would delay the production of EVs in general and imply logistical issues in the rural areas. Moreover, it's a risky investment without a guaranteed benefit, and the upfront cost is likely why many large companies would abide against it, and also why we didn't choose it as our main solution.
So production cuts, cutting production of the vehicles.
We're out of time.
Alright. Miles, how did the group decide to include some of Ty's research into the overall presentation?
So, Ty did a lot of he contributed most of the labor shortage research that we did, like how they mistreat a lot of the workers in the mines. That kind of played into being a big part of what we base it off, because not only does the mining contribute to global emissions, but it's also causing fatalities, which a lot of countries are really unhappy about. And so we kind of built off that and tried to incorporate that into our solutions, where if we can start recycling these batteries, then there's less demand for these miners in there, which means less death, less labor shortage, and less harsh treatment towards them.
Ty, in the future, what change would you make to group norms, and how would you expect that to improve team projects and presentations?
One thing I would change is how we trust each other. One thing I had a problem was I was worrying more about others than myself, and it turned out that we did just fine, and everybody had great resources, evidence, and we had great communication. So I should have just taken that as a great opportunity to just kind of work on what I needed. So
Jack, what is an example of a compelling argument from one of your peers' individual reports that you guys decided to exclude from the presentation, and why?
So Chris had a really good argument on the futuristic point where it wasn't sustainable, and that would change most of our argument, because it was very specific into what he would say, like cutting off the mining supply that was one of our original solutions would change the amount of cars produced, thus destroying the economy in some aspects. So that was part of an argument that we kind of just left out, because it would make our argument really complex, and we didn't have enough time to add that in.
And Christopher, what is the strongest counter argument to the solution that you guys proposed, and why do you say that?
Honestly, our strongest counter argument is just implementing it into large companies, because they already have a set plan on how they want to go about making EVs. And for us to just implement a new solution is really hard to ask for, because it's a really big demand, and it would likely imply things that they don't want to face. So it's just too much of a